Hello, everyone. Welcome to Powering Up Your Projects with Scene Graph and Verse. Whether you're new to Scene Graph or new to UEFN, you've come to the right place. So we'll get started here. So a little about me. My name is Evan Brown. I'm a programmer writer at Epic. Kind of a strange title, but basically I make game examples, documentation, and the occasional template in UE and UEFN. The TLDR is I make things and then I write about how to do it through documentation and other examples. Basically, I ask myself a lot, how do I help people have fun? So, we got a packed agenda today. We're going to be going over the what and the why of Scene Graph, Verse and its many versisms. I'm going to take you on a sample Scene Graph journey. We're going to be creating a platformer both in Scene Graph and in Creative, and to show you the differences between the two. And then we're going to be talking about Scene Graph, the future, and you guys. All right, let's get into it. So, Scene Graph, what is it? Why is it? How is it? So, at its core, at the absolute most basic level, Scene Graph is a unified structure that connects all the different objects in the world together. Whether you've worked in UEFN or UE, you're probably used to hierarchically representing your data in the outliner, right? You have objects nested under each other, parented, child objects. Basically just a way to organize them, but Scene Graph takes that a little bit further by organizing all your different objects in the scene under one simulation entity, which sits at the very top. Now, while that might sound really, really simple, ultimately it's a guiding framework for the future metaverse that we're trying to create. I have an example here on the right of a Scene Graph setup where we have at the very top this object that represents the house itself, and then for each of the different subsections, the roof, the walls, the floor, we have more nesting of these different objects to create a whole, right? Now, the really big important thing for you to know about is that we're going to be transitioning away from the Unreal Engine actor system in favor of a new system of entities and components. What's that? So we'll start with talking about entities. Entities are basically just containers, right? You should think of them as an empty box. They start out with nothing in them. They're just object. That's it. But entities can act as containers both for entities and for components. What's a component? Well, it's something that provides data and behavior to that entity, right? When I say an entity starts out with nothing, I really mean it. It doesn't even have a transform. It doesn't even have a place in 3D space. If you want to add that to an entity, you have to add it through components, right? You add a transform component to give it a location. You add a mesh component to, actually be able to see it. You add a light component to allow it to shine light, that sort of thing. And so by doing this, by building up these entities in this way using components in a compositional manner, you can create far more complex objects than you were able to before. And when you land on a design that you really like, for instance, that house from the previous example, that's a nice collection of entities, each with their own different meshes and transforms. You can save them in what's known as a prefab. So when you save a prefab, it saves that entire collection of entities and components as a single object that gets exposed as an asset, right? So you can save that prefab and then drag it out into the level, and boom, you have an entirely new version of that entire collection of entities and components, right? So you start with one house, you really like it, you drag out the prefab of the house. Okay, now you have 2, 3, 4, 5 houses, you got an entire suburb. So that's entities, but let's talk about components, right? I said components add data and behaviors, but it might not be immediately clear what a component is. Well, it's a lot of things. So firstly, there's a couple of built-in features that are components. Through the API, we provide to you things such as transform components, so you can, place your object in the level. A mesh component, so you can actually represent, the object in space. And then things like light components to, shine lights. Basically, a set of building blocks that are really easy to get started with and get working with. Further than that, components can also be your own user-defined verse code. Now, traditionally, you've been used to writing verse code and then, you have to put a creative device in the level, drag it out, assign editables, and then you run code from that when the game begins. Instead, you can write that same code as a component. And when you do this, instead of having a central object in the level that runs code, that manipulates other objects, that dictates what they do, you can put this component on an entity, and the data and behaviors from that verse code become part of the entity itself. As an example, we have here this super basic my cool new component, right? And then in onBegin simulation, which runs when the component begins simulating, it just does hello world, right? Super duper simple. But instead of like a verse device where I drag this out, I could put this same component on every single entity, every single sub-entity in that house I showed you earlier. That would probably overload the screen, might not be the best design, but it's something you can do. You can run code from each of these individual entities. And then kind of as I alluded to earlier, components can also be your own assets. So meshes you import, VFX you import into your level, even prefabs, right? If you save a prefab, you can expose it to verse, and by extension, your verse components through your assets.digest.verse file. Meaning you can instantiate these objects at runtime. You can swap out meshes, spawn VFX, do all these other sorts of things because you can spawn them as components and they become part of the entity. So back to entities, right? I said we're moving away from the Unreal Engine actor system, but not really the why of it. Well, there's a couple things. So unlike actors, which have a lot of inherited behaviors, a lot of inherited components that make up what they are, entities aim to provide the most minimal building block to get started with, right? When I say an empty container, I really, really mean it. By putting components on these entities, you add weight, you add data, you add behaviors to build up an object from scratch rather than having to start from an actor, right? And all relations the entity has to the level, such as its position, its mesh, its ability for you to interact with it, come from said components. Here's a bit more of an in-depth entity prefab setup. We have this lamp prefab here, right? That's how to be referenced in the assets file. And then this is made up of two different entities. First is the lamppost, which has three components. Got a transform to give it place in space, a mesh to represent it, and then some gameplay element, right? This could be a piece of verse code or a interactable component, something that lets you play with it. Then underneath it has a sub-entity, which is this lamp, which again also has three components. It's got a transform, a mesh, and a light. And so if just two entities, you can already create a functional piece of gameplay in your experience, save it as a prefab, and I like this lamp, I want to reuse it, save it as a prefab, drag it out, copy it a bunch of times in the level. If, for instance, I say, I don't like the wood anymore, I'm not really sure of this design, I can go to the prefab editor, swap out the mesh on the lamppost, and then update this lamp for every single lamp in the level immediately. And I could do that on an individual level too, right? I could make a whole rainbow of different lamps by just changing the light on each individual one. But you have the flexibility to do it either way. TLDR, structure content the way you like. So, verse. Verse is the scary thing, but I'm going to guide you through it here. So, when talking about the relationship between scene graph and verse, we kind of first need to talk about, the metaverse itself. And the metaverse has a couple of challenges that need to be addressed to actually work. First off, it needs to be always on, right? It never needs to turn off. Everyone's islands need to keep simulating. Everyone's experiences need to keep going. The whole simulation should never crash. And then content in the metaverse needs to be transferable between worlds, right? If I have a really cool car design, and you're hanging out on your island, I should be able to drive it into your island. You import all the different assets for it and transfer it in a way that you don't have to import a million different libraries and other random things. By sticking with a system that's a bit more unified, such as entity and components, we can start to facilitate that. Now, speaking of that car, authored content also needs to be strong and it needs to be stable in this metaverse, right? I shouldn't be able to make a car entity that runs a piece of verse code that crashes your experience when I drive in, right? Like it finds every single entity in your scene and then deletes them. We don't want that. So verse kind of provides answers to a lot of these challenges. So scene graph is designed for verse. If you're going to be using scene graph, it's best to get a good hold of verse. Verse provides the strong type checking and backwards compatibility that scene graph needs to function. So verse provides a lot of really strict guardrails for you to operate between, but it's those strict guardrails that make content strong and make content stable in these experiences. Verse is also backwards compatible, right? So if I publish a really cool piece of code, like, I don't know, Evan's cool city builder code, right? It instantiates a whole city when you run it. And I make it public and it gets really popular, people download it, and I get bored with the project and I abandon it. If you come in and it's like 2030 or something and you're running verse v5, you download my code because you're like, oh, this is kind of cool. You start running it, it will run in your level when you import it because verse has this backwards compatibility guarantee. And that extends to scene graph objects, right? If you have scene graph objects running code, you should be able to have them be backwards compatible, not break when you try and interface with them later in these metaverse experiences. Verse also provides globally shared namespaces, right? So if I write a piece of code and it's public, it exists at some namespace like evan.brown@epicgames.com/michaelcitybuilder/michaelcitybuilder.verse. And that namespace is unique to me. Content I publish there, we're not going to run into collisions with names. Whichever one of you makes the first like tycoonbuilder.verse file is not going to have ownership over that name forever. You will be able to share it, and you will be able to try other people's code without running into these namespace collisions. Verse is also transactional, which is honestly one of its biggest superpowers. Anything that you do in Verse creates these transactional contexts where if something goes wrong, you try and access an array out of bounds, or you try and dereference a null pointer, you run into some issue, that entire transaction can be rolled back. It never gets added to the heap. It doesn't break your game when that happens. All of this gets rolled back. Your content keeps running. Your island keeps staying on. I have an example here, right, where this grant team weapon function, it takes a player and it gets their team by getting the play space, getting the team collection, getting the team for that player. All of those function calls are failable. And if an error occurs at any one of them, this entire context gets rolled back. It doesn't break your experience. Everything keeps chugging along smoothly. And then ultimately, Verse is designed to be easy to learn and easy to use. A lot of things that are traditionally quite difficult in other programming languages or serve as big barriers to entry, such as memory management, multi-threading, even multiplayer networking, Verse provides the ability for you to just get up and get started. You write a piece of Verse code, you drag it out as a Verse device into your level, you hit play, you invite all your friends, okay, you're already playing a multiplayer game with said code, right? So I talked about Verse and Verse components, but let's take a look at one real quick. Because I think this illustrates a lot of what SceneGraph can do that you previously would have a lot of trouble doing with a device-driven setup. So here we have this custom Verse component. In onBegin simulation, we find each entity in the scene with a light component. We query the simulation entity, which again is that top-level entity in the scene. Every single other entity is under it. We then call find descendant entities with component, passing the light component. So we return every single entity in the scene with a light component. Then we create a new particle system component named VFX of type blowing particles. What's blowing particles? Well, actually, it's a custom VFX asset that we expose to Verse through our assets file. We then set it up and add it to the entity with the add components call and then enable it, right? And even though this is a super simple looking example, right? It's not that many lines of code. It's kind of important to think about what we're doing here, right? We're searching literally every single object in the scene, right? We're not differentiating whether it's a creative object. We're not differentiating whether it's a creative device or a decal or a Lumen Exposure Manager or some other thing. We're searching through every single entity in the scene, finding them all based on some unified standard, that being whether or not it has a light component, creating a new object, and then attaching it to that entity. And not even really attaching it, we're making it a part of said entity by instantiating it as a component. This is really, really, really hard to do with devices and really, really annoying. But this unlocks a lot for you in terms of your ability to manipulate and query and just customize the way that you interface with data. So, okay, that's a lot about theory. I've done a lot of talking so far, but let's get to the meat and potatoes of this. So I'm going to take you on a bit of a sample SceneGraph journey. First, we're going to build a game the devices way, traditionally in UEFN. And then we're going to build it again this time, but with SceneGraph. So I'm going to take you guys back to the far off year of last year. So we, on the programmer writers team, whenever a new feature comes in, we try and make example content for it. And our thought process at the time is like, wow, SceneGraph is new. Oh my God, there's so many new tools to work with. You're telling me we can instantiate objects that run their own verse code dynamically? That's insane. And so our guiding principle whenever these things happen is, all right, what's the very first thing a user would try to make? So thought about it for a little bit and settled on, let's build a platformer. Why a platformer? Well, I think a platformer illustrates a lot of SceneGraph's biggest strengths, a lot of its best potentials because of the simplicity of it. So when you think about a platformer, right, player spawns, they have to get to some end goal, navigate a series of obstacles. At its absolute most simple, an obstacle could be something like a platform over a pit. It's an object in the world that has a transform, so it knows where it is, and it has a mesh. And what's that? Ultimately, it's an entity with a transform component and a mesh component. And so by saving that as a prefab, you can instantiate these platforms all over your world, all over your game, copy it a bunch of times. Okay, you made a platformer in 5 minutes. What if you want that platform to do something else? You don't want it to be static, you want it to move. Okay, just go to each platform you want to exhibit that behavior, add a movement component. Now, suddenly you've got moving platforms. What if you want them to damage the player when they stand on it? Okay, add some sort of damage player component. Maybe they explode, maybe they spawn NPCs. All these things are possible through adding components, through adding behaviors. You don't have to make specific verse devices for each of these. You can just add them on the fly and then save them as prefabs to, build very quickly. So we get quick iteration, easy scalability, dynamic gameplay. We can also spawn these things at runtime. Again, I really want to emphasize this fact because this is something that's really, really crazy. With each of these prefabs, if they're running verse code, if at runtime, let's say I'm walking along, I step on a switch, I want to spawn a set of platforms in front of me that move back and forth. I can spawn these prefabs and they'll start running verse code immediately, going back and forth. I don't need to create a device in the level. I don't need to assign editables to it. It just happens. So, like I said, we're going to build it with devices first and then tackle it with scene graph. So let's list some requirements. So I want platforms. I want them to move to some position over some amount of time. I want them to rotate and scale appropriately as they move. I want them to be able to go forwards, backwards, loop repeatedly. I need different movement modes. I want them to speed up, slow down, wiggle all around, do all these sorts of things. So, okay, well, we thought about it for a little bit and realized, oh wait, we already wrote this. So if you haven't looked at the documentation in a bit, this is a screenshot from the animating prop movement tutorial in UEFN. This is using the Fall Guys template island because we wanted to show off that island, but we also wanted to show off how creators could use animations to move objects, right? If you've tried to move objects before, say with move to or teleport to, it gets kind of a little jittery, like dut, dut, dut type of movement, especially if you're running on a loop, for instance, if you have an object following the player. And so we figured, okay, we have this tutorial. It already shows off a lot of the best strengths of making a platformer and doing animations. So we'll redo it in scene graph for a super duper easy lift. And I'll show you quick right here, a video of what the original looks like. So we have our being who spawns. That's me. We get to this first set of platforms. They're using animations to move back and forth between two different targets. We go up, we go to the next set. These ones are using rotations. They're spinning. We clear that. We get to this next one. This one's modifying the transform component, transform scale to scale up and down. We get to the end. This one's using both rotation and movement at the same time. Clear the final obstacle, get to the end, big thumbs up, we got it. So, how does this actually look in verse right now? So before even starting, it's kind of important to think, those platforms I'm moving, right? How am I doing that? Well, those are creative props, and creative props don't really have any data, right? They are objects that exist in the world, but they're not something that can run verse code. So instead, I need to create some sort of movable prop class. So I create this movable prop class. It's got the prop to move, a reference to the creative prop in the level, how long it should move for, the type of movement easing, which is that speed up, slow down movement, and then a location to start from and whether it should reset back to the start. Then, animations. I'm not going to get too deep into how animations work in this talk, but the long and the short of it is animations are split into a number of keyframes. Each keyframe says where the object is at some point in time and then how long it takes to get to the next keyframe. So we need to do a bunch of math, linear interpolation to find the end transform. We assemble each of the different keyframe pieces of this animation. Then we add them to an array and play them on the animation controller for that creative prop. But if I assemble this code right now and I hit play, nothing will happen. Why is that? Well, that's because something has to get them moving, right? If I write this code, these movable prop classes just kind of exist out in the ether. They don't really do anything. They don't have a way to interface to their level, and that's why you have to use a verse device. So we have this prop movement initiator that has a reference to all these different animating props. And then when the game begins, it needs to go into each of them, call some setup function to actually get them started and actually get them moving. And this is a very verse device-driven way of looking at things, right? Like I said before, these objects just exist in the level. Creative props don't know how to run verse code. They don't know how to move. And so we need this movable prop class to essentially come in, act as like a giant hand moving a chess piece, pick them up and move them to where they need to go. They can't communicate with each other. They can't share data with each other. If one of them wants to know, okay, how far along is the player in the game? Or has a player reached a certain point, so I spawn a bunch of enemies? It doesn't know that because at the end of the day, it's just a creative prop. If something wants to know about the world that it's actually working in, it has to go through the verse device. The verse device is the one that holds all the info. It's a very central model of doing things. And it ends up being a lot. It's quite heavy. So the whole thing ends up being around 400 lines of code. We have to set everything up ahead of time, right? If I want to put a new platform in the level, I have to assign the editables, I have to assign the targets, I have to assign the keyframes, I have to do everything ahead of time. And dynamic manipulation ends up being super, super difficult or super, super annoying. So say I want to add a platform that moves when the player steps on a switch, right? I have to spawn the prop, I have to spawn the targets it has to move to, I have to create a new movable prop class, I have to assign all the values to that class. I have to generate the keyframes. I have to add them to an array. I have to hit play. But then I also need something else to come in and call that setup function to actually get it moving. It just ends up being a giant pain. It's a lot of work to do things dynamically. And if I want new behaviors, well, that requires new devices. Well, if I want a platform to, like I said, damage the player when they stand on it for too long, sure, I could add that functionality to the base class, but that's not really a good design. Instead, I probably want a different verse device or a different type of verse class to come in and do this for me. And so it just ends up being a lot of groundwork to actually get set up and get started. So here's the big draw. What about scene graph? So we're going to take off our UEFN hats right now, our traditional verse device-driven hats, and we're going to put on our scene graph hats. It's time to think like a scene graph dev. So instead of being controlled through a central device, a central system of managing objects in the world, entities should be responsible for themselves. Components that you add to those entities add data and add behaviors that add on to that entity in a compositional way. You also have built-in components, right? You don't need to write your own transform component. You don't need to write your own mesh component. Use built-in components to speed up your development. For example, the keyframe movement component, which we'll get to here, is a way to do keyframe movement in a pretty simple way as compared to what I just showed you. And finally, be dynamic. Like I said, you can spawn these objects that are running verse code during runtime from anywhere, which is insane. So let's take a look at what this looks like in scene graph instead. So here we have this animate targets component attached to the entity that we're trying to move. I think it means it gets the keyframe movement component from that entity. And then in this example, we defined our own quote unquote segments class just so we could pause at individual points along the animation. And we just loop, we go through each of our keyframes. If we reach a segment, we sleep for a certain amount of time, keep playing. We just loop this over and over and over. And so instead of having to have one verse device that we assign everything to, we just attach this to whatever component, we attach this component to whatever entity we're trying to animate, and then set up the targets in the level for it to move to. And it ends up looking like this. This is a tale of two entities. So what we have on the left here is a boring gray block moving in a boring flat plane. And on the right, we have this entire building that we're moving back and forth. Under the hood, these are literally the exact same thing, right? This is the exact same prefab. It's the exact same collection of entities and components. Each of these has a mesh component, a keyframe movement component, and this animate to targets component that we wrote. And while they're exhibiting similar behaviors, the feeling of this is extremely, extremely different, right? Because entities can be whatever you want, because they're defined by the components you add to them, you're not stuck to just, okay, I have this block and I can move it, right? That block can be anything. You could add lights to it. You could add a damage type script to it. You could have it spawn NPCs or do some other function. That building, right? You can instantiate a whole city of buildings moving like this. Probably shouldn't do that. Your game might run at like 1 FPS and your computer might explode, but you have the ability to do that. Swap out that mesh for the sun if you feel like it. So to really hammer in on this point, I'm going to show you what the process of creating a new platform in the editor in UEFN looks like. And I'm going to show you it in scene graph. So I'm going to have to talk really, really fast because this is sped up by 3x. So here we go. So we copy the platform, we copy the targets for it to move to. We have to correctly position each of the targets and the platform itself. We have to rename the targets so that they're easy to find. We have to rename the platform as well. Then we have to go over to the verse device. We have to create a new entry for the animating prop. We have to assign the platform and each of its different targets, make sure everything's set up correctly, save it, and then we're done. And that whole thing was about 22 seconds. In real time, it's about 1 minute. Now, I'm going to show you the scene graph version of this, and you're going to have to pay a lot of attention because there's a ton going on here. This is really difficult. So I'm going to hit play. So we have this prefab here for moving platforms, and we drag it out into the level. Oh, that's it. And so you can see how you can use this system to just really, really speed up your development. And again, this thing runs verse code. I can spawn that prefab set while the game is going on, and it'll just get up, it'll get moving, it'll get doing what you need it to do when you need it to do it. It's easy. It's fast, it's dynamic, it's reusable. We need no diverse verse devices in the level. We can dynamically instantiate these things. It's super reusable, it's super customizable. This is a component-driven way of looking at things rather than a verse device-driven way. Components add behavior, they hold data, and this allows them to query each other for information, right? Entities are coordinated as part of a larger, broader scene. They don't exist independently of each other. Since everything's organized under the simulation entity, you can do queries up and down the tree for entities to know things about each other, share data, respond to certain events when things happen. Basically just make a significantly more connected experience than you were able to do so previously. So let's talk about the future here. Now, you might be wondering, okay, Evan, well, you showed me how the platformer looks in UEFN, and that's cool, and then you showed me some verse code, and I mean, that's cool, and SceneGraph is neat and all, but why didn't you show me the platformer in SceneGraph? Well, there's a couple limitations to address. So there's still a lot of underlying components that are not yet exposed. We expose things such as transform, mesh, lights, keyframe movement, all these things, and we want to provide you a really strong set of tools to work with. And that tool set is only going to continue to be expanded upon over time. But other key systems such as physics are still in the works. This is the reason I didn't show you the platformer. But systems like physics are going to require more work to interoperate, especially with characters. The eventual goal is to have 4 characters be part of this entity and component system, right? It will take time. It will be something that is rolled out slowly over time. But eventually 4 characters themselves will be entities and act as a series of entities and components. And then another large one is that fab support is still in progress. I know a lot of you guys like to, reuse assets either that you've made or that creators have made, and then fab is a really good marketplace for driving your ability to discover said assets. But that'll be coming later. That's actively being worked on. Itemization, which is on our roadmap, is powered by SceneGraph and will be coming later as well. So if there's anything I want you to take away from this talk, other than, okay, I showed you some cool examples, but that's about it, it's instead to start thinking like a SceneGraph dev, right? Saturday is coming up fast. I'm sure faster than some of you even imagined. But there's never been a better time to start thinking like a SceneGraph dev. So remember, an entity can be just about anything. It's just a blank container. You don't have to think of it as like it's some hard-coded block in the world, or it's like an entity is a car, or just some other thing. An entity can be whatever you define it as, because you add components to add data and behaviors to make it what you want. That makes them super simple and super reusable, right? Customize these objects in the way you want, reuse them in the way you want. If you have a prefab you really like, drag it out into the level, copy it a bunch of times, want to change individual ones, just change it at the individual entity level. And then components are applicable to any entity, right? If you write, let's say, a component that spawns guards when the player collides with the entity, or something like that, right? Like maybe you're making a museum heist game. You can apply that component to quite literally any entity in your level, because entities work in this compositional manner. Now, I say components grant data and behaviors, but I do want to emphasize, let your components grant data and behavior. It can be easy to fall back into writing code in this way where you have some central management system that dictates what every other object in your scene does, but Instead, you now have this opportunity to let those objects decide what to do for themselves. Let them make their own decisions. Let them choose what to do based on the data that's granted to them. Don't have them just be managed by essentially the invisible hand of your giant verse device that floats out here in the ether. But at the same time, don't be afraid to combine what's here with devices and other APIs. Creative devices are still incredibly, incredibly useful, right? I myself know that without mutator zones specifically, I would be lost like a ship in the sea. Don't be afraid to combine what's here with SceneGraph, with those devices, with those other APIs to make the best experience you can. Ultimately, I want you guys to go beyond the SceneGraph. Go beyond what I've shown you here. Go beyond anything I can tell you either through examples or through docs. I've already seen, frankly, really silly, really ridiculous, really amazing stuff that people have been putting out on Twitter and other social media, even in the SceneGraph's experimental stage. Stuff that I wasn't even imagining was actually possible. Very janky, stuff that breaks the game, but ultimately incredibly, incredibly cool. And I know that whatever you guys make is going to far surpass anything I could imagine. So I'd like to just say thank you to everyone and then open it up to Q&A.